Thanks for the introduction. This is going to be a bit statistics heavy. My background. These days we are all on LinkedIn, so I don't want to give a full rundown, but I figured that it would be cool to show all the different data sets I have looked. So I started my career in astronomy, and not many people know this, that even before this became a thing in industry, the first big data science was astronomy, followed by genetics. So we had more data than Google and Facebook back in '98 or so. Like, this is before even I did astronomy, but anyway. And after that, I decided to move to industry, and I did, look at some e-commerce data when I was working at Gap, some social network data also, and lately, I'm working at Uber. So, just a brief introduction. We all know what Uber does. So basically, why do we care about hypothesis testing, and what is hypothesis testing? So I give you an example. So you must have seen in the news that Uber introduced tipping. So where you can, if you take a ride, you can tip, and Lyft also has it. So the question that internally we would like to ask is, how is the sentiment of driver get lifted, when the tipping is introduced, right? So that's one example of experiment that companies would like to do to figure out that whether this feature that is introduced, in this case it's tipping, has it improved? If yes, by how much? And the hypothesis in this case is, of course, the driver's sentiment gets positive, and we want to measure how much positive it is. So this is just one example I gave. We have thousands of these types of experiments running. The scale of these experiments is, of course, global. We have, and these statistics are actually outdated. We are probably in more than 800 cities now. But in terms of why we experiment, why any company experiment, these days what companies have realized is we are sitting on this treasure trove of data, all kinds of data, right? Marketing, we have data about customer satisfaction, we have internal data, etc. So really the question that companies want to ask is, what can we learn from that, and how can we take those learnings and turn it to advantage? So the way, sort of high level flow of how an experimentation or a hypothesis testing in industry works is, we first form a hypothesis. Like the example I gave, the hypothesis is the sentiment of driver will increase. So then you go to experiment. So when you go to experiment, you experiment. In this case, you are experimenting on your drivers. So you have these features. In this case, it's the tipping feature. So you give half of your cohort the tipping feature, and the other half you do not give, and you measure the difference between the two. So that's a very simple explanation of how this experimentation is conducted. So, and the idea is, if everything else is just nothing is being perturbed anywhere, everything stays constant, and that's the only feature that has been introduced, then we will know by measuring the sentiment how much that feature has improved. So that's the basic idea. No, the sentiment is how happy driver is. So we have internal ratings. We don't go that way. No, that's a big no-no. That's a privacy issue. So we ask drivers to give internal ratings, just like users can give ratings to drivers, and drivers can give ratings to users. Those are the external facing. But drivers can also give ratings like how happy they are, and we can measure that, like if it's increasing over time.
In this case, they will say tipping is good.
Yeah, but the question is how much we are, like, we want to quantify that in terms of, like, yes, it's a good, that's a binary 0-1, but how much it is improving the sentiment? 10%, 20%? If yes, like I will get into the details, but that's a global number. But maybe in San Francisco it's one number, in India is another number. So things like that. So experimentation. This is true for all big companies which operate across different platforms, right? So you have desktop. In Uber, you don't have desktop, but multiple mobile apps. And essentially for Uber case, it's a marketplace, right? So on one side you have users, on the other side you have drivers, and Uber is basically a mediator. So, and there are hundreds of interaction happening. 100 is actually a small number, but there are a lot of interactions happening every day. And so experimentation in these cases is a scalability question. So what type of experimentation we can do? Well, I gave one example. The other example is, like in this case, it's a very simple thing. You probably cannot even see it unless I point it. So this is actually user-facing. So, on the right-hand side, there is this free ride feature that was introduced at some point. So how many people are, clicking on that or using that feature, right? So that's one example. And also, you can also see some subtlety here. Like, so it's not just, the difference in the, I guess in this case, that one feature is introduced, and also you can see that maybe some color and some design has been changed. So we can experiment about all kinds of things, like, how the, user interaction changes as you change the design of the app itself. So for example, in this case, if we make that font really small, maybe people will miss it, So, and this is another example I was telling you, like, we Uber introduced cash in India and South America and some other countries, and we wanted to measure what's the impact of that is. An impact of a feature like that is multiple. So first impact would be on the user side. So users, some users in certain geographical region want to pay in cash. They don't want to use credit card. It might also be, so that's a positive thing for the user. But at the same time, it can be a negative thing for the driver, because now they're, spending more time in dealing with this cash and all that instead of just, hop in, hop out. So it spends more time. So really, it's not a very simple thing. Hypothesis testing in real world is a complicated thing because, real world is messy. So there are two aspects to data science. One is hypothesis testing, which is, something has happened and, or something has been introduced and we want to measure that impact. And then on the ML side or the machine learning side of it, we want to predict, what the impact is going to be a week from now, a month from now. So let's say in the context of driver tipping, one relevant question we might ask is, now that the tipping has introduced, how does that impact the supply hours of the driver? Or how does that impact the trips of the driver? Yes?
Yeah, I was just wondering, this is very exciting, but like everybody tells me deep learning, machine learning is magical. What I was thinking is, somehow you have the comments from the riders, you have the comments from the drivers. It would be very interesting to see, like run some magical algorithm and they say, this section, give them tips. These guys want extra holidays. These guys want to work from 10 to 5. So somebody tells me that, data is all the gold mine. But if you have to think and say, let me introduce tips, it's so commonsensical that you give me a tip, I'll be very happy. Give me $5, I'll be singing your name for the next 5 hours.
Yeah, so at the simplest...
Rocket science here.
No.
Where's the juice here?
Yeah, so the juice is, and I probably won't get there, but the juice is, so if I want to ask, well, what type of profile of the driver is most impacted by tip? Because, let me give you an example. Let's assume that someone is driving just occasionally on the weekend. He has a real job, right? Maybe that person doesn't even care about tip, okay? For example, or care less about tip. Another person, maybe this is the full-time job, right? So that person might care more about the tip. So what is that profile? And we want to know that, right? So the devil is in the details. Sure. I can skip the 10 slides.
Sorry, Suman, I think you got.
Yeah, I got distracted. Yeah, so right, so the I think your question was like how the hypothesis testing is different from deep learning, right, or machine learning.
Is it asynchronous to it?
Yeah, so is
Is it one after another? Right?
exactly. So I see this as sort of like two sides of a coin. For every problem you want to solve, I would say not every problem will have a prediction, although these days we are almost getting there, like everything we want to predict. For example, I can give you, we predict, so, Uber has everything in-house. We are not on cloud anywhere. So we have in-house cloud, in other words. And we want to predict how many hardwares we want to buy next 6 months, given the, increase and all that. So we apply machine learning there. And that has a huge impact, in terms of cost and all that. So that's one example, right? Now, is there a hypothesis testing there? Probably not, because we know that it is increasing, right? In the context of the tipping, the reason I brought that up, because that actually has two sides to it. One is, yes, it is increasing the sentiment of the driver, and we want to know, what profile of which country, like age 30 to 35, who is doing trips on the weekend in India has more, impact on the tipping versus no. I'm just making it up. I think I understand what you're saying. Basically, you're saying that driver sentiment can be impacted by multiple factors. Tip is one of them. Yeah. So essentially, what you're talking about is there is a technical term. It's called collisionality effect. I will not get into that point. It's too advanced for 90 minutes intro lecture. But yeah, people can Google it out. But yes, I mean, this is true for all marketplace type company. In Amazon, Amazon is a marketplace, eBay, another marketplace, right? So Uber, Lyft. The high level thing is I introduced a feature, and my hypothesis is that feature impacts whatever the lift is, but there can be multiple other things that are happening. Some of them might actually drive it negative, and I can see a net negative. Does that mean that that feature is actually negative or not, right? Yeah, it's an incredibly difficult problem to solve. Machine learning is actually being used. It's also, the collisionality effect is really at the cutting edge. Like you can see papers being written in 2016, 17, from Google, Amazon, So it's too complicated, but yes, it's not a 100% solvable problem.